Audio's live. And we are live.
Alright. Cool. Everything looks good. Cheers. My coffee cup's on the floor. Okay, we're live, right?
We are.
Cool. So, we are David and David.
Redshirt David. Other.
And today we're going to build the Thimble compass kit, which looks like this is the PCB for it. And I guess we'll just go ahead and get started. So,
is there anything that you want to talk about regarding, like housekeeping stuff, shipping? We shipped out the kit.
Yeah, so if you haven't received the kit yet or haven't received a tracking number for it, send us an email. But I believe all of the kits have been shipped out. We transitioned from using ShipBob as our fulfillment warehouse to actually doing it ourselves, which has been pretty beneficial.
And not that bad.
It wasn't that bad.
It wasn't that bad.
It was a lot of work, but it wasn't bad.
No, it's kind of zen.
Yeah.
I found a zen to it.
Yeah. So we shipped out everything this past week and the week before that. So most of you have actually already received them. And if you haven't, you should be receiving it very soon. We are sending out beta kits for the next kit and a bunch of other ideas that we've been working on in the next few weeks to months. All of you who signed up for the beta testing email list should be getting those pretty soon. You can see a little bit of smoke coming off of this soldering iron because it's not been used yet. It's brand new. So the nichrome is off-gassing a little bit. Other housekeeping stuff. I think that's about it. I think I'm ready to get started.
Okay. So we are going to be following the instructions that you can find on the learning platform. We're also going to pull them up right now. Just to have. So we're going to build it just like you would at home. We're going to be using only parts from our toolkit.
Yep.
That's on the store? It's not on the store.
It's on the store.
Is it?
Well, it's not on parts.thimble.io, but if you log into your account, you can buy a toolkit.
Gotcha. So yeah, only using the stuff from the store. Yeah.
Yeah. All right, so we have our nice little intro and a bunch of videos. You can watch the videos, of course, but we're just going to go through the text instructions.
Okay. So, do you want to lay out all the parts?
Yeah, so I have the compass kit here, and then move that a bit out of the way, and here are all of the other parts in this nice little bag.
Yep, you should have 16 green LEDs, 16 resistors, 4 headers in a little bag.
Yep.
You have the Velcro strip, or hook and loop.
Yeah, the technical name for it.
Battery pack. Over there. Okay.
Cool.
I think we can start.
Yeah, let's get started.
So the first step, soldering the resistors.
All right. So it's useful to kind of bend the resistors before you stick them in. And the resistors go, you can see this, right?
There you go.
Go through these holes in the middle of the circles.
Yeah, so not in the circles, between the circles. And the resistors, they have no polarity, so they can just go in, with the colors going one way, the colors going the other way. It doesn't matter. Once you put them through, it's usually helpful, actually, with like all through-hole components. Once you put them through, to bend the leads on the other side a little bit, just so they stay in place and they don't fall over if you have to turn it over. Yeah.
Try and listen to you vamp. It's good.
These are important things. Yeah. And it's a good idea to have the resistors flush with the PCB surface, It's not necessary to get a good electrical connection, but it does make your project, slimmer, looks kind of nice. But if they're not all perfect, it's okay.
Nothing's ever perfect.
No. So while David is doing that, I'm going to pull up a picture. A lot of people have been asking, or at least we've seen on the forums, some people are having some issues with soldering if it's your first time soldering. I know that can be kind of difficult, especially if you're just kind of looking at videos and pictures and not having somebody behind your shoulder, like a tech teacher, telling you, oh, this is a good solder, this is a bad solder. So I'm going to try and find a few pictures of like good solder joints. We are working on a new solder tutorial. That is a thing.
Yeah, now that we've kind of got our rhythm down as far as video production, we're going to start putting out a lot more video content.
With good audio.
Yeah.
That's a big...
Yeah, it was kind of frustrating during the Compass video shoot.
Yeah.
One of our mics turned out to be bad. So we had to use our backup microphone. The audio quality is less than what we would have liked.
Okay. So David's going to put in the resistors, and I'm just going to cut to this really quick. Or not. That's fine. Love Firefox. Okay. So here is just a few pictures of some good solder joints. Well, 2 good ones, and then a couple other ones. So you can kind of see in this picture and in this picture, they kind of end up looking like Hershey Kisses.
Yeah.
That's what I was told way back when. You want your solders to look like Hershey Kisses. Solders like this one, and this one all the way to the right, and 2 from the right. Electrical connection, like they are electrical connections, but you don't want to go for that. If you have solder wick or a solder sucker, those would be 2 ways to get rid of some of that solder. But electrical connections, they're connected. So these 2 are kind of weird. Might not be solid electrical connections.
Yeah. So those are cold joints, and the one on the far left is a very cold joint. And it kind of the picture there kind of explains how you get those joints, but basically for all of the cold joints, the pad isn't heated up enough. So when we actually solder, which I'm about ready to start doing, just gotta flip this over. You want to make sure that you heat up the pad with the soldering iron so that you get a nice joint.
Okay.
All right.
Is that one good? Do you want to show them what a good tin soldering iron looks like?
Sure. So.
Yeah, we can see that.
Yeah, cool. So there's my soldering iron. I put some solder on it so that it gets nice and tinned. So you kind of see this is basic idea, and then I'm using this. Yeah, you can see that too. Sponge, brass sponge, just to clean off the tip.
I think these soldering irons, they come with the little normal sponge, right?
Yeah.
Yeah, and that just has to be wet before you use it, but it's the same kind of thing. You want to just clean off your soldering iron. It's not going to look like the bare metal. It should kind of look like it has solder on it.
Yep.
Yeah, you're not going to get all of it off, which is fine. That's how it's supposed to be. The solder acts as like a protective coating, which keeps the iron from oxidizing, which is bad. It's like rust. Yeah.
Exactly. So
yeah, what are you doing right now?
Basic idea for a good solder joint is you take your soldering iron, put it right on the pad, touching both the pad and the lead of the through-hole resistor in this case, and then you push your solder into the pad, and it melts like that. And then you pull the solder away, and then the soldering iron away. You can see I got this one a little bit too hot, so there's a little bit of mark on the PCB because I left the soldering iron there too long because I was trying to demonstrate. But it still works.
So sometimes the tip of the soldering iron doesn't get too hot, or maybe, you know, I have too much solder on it. This is just something I kind of saw when I was teaching people to solder at the event that we went to. So sometimes using the side of the soldering iron is a bit more consistent.
Let's move this over here so it's not
Makes more sense.
not right on the microphone too.
So do you want to do a couple of solders where you're kind of utilizing the side of the tip of the iron? Because that's definitely a thing I see people do.
What do you mean? Like that?
Yeah, kind of like that, making like a kind of a tent with the tip of the soldering iron, then pushing the solder kind of almost under the tip. Yeah, kind of like that, making like a little, yeah.
Like that?
Yeah.
Cool.
That's something that it's kind of easier to teach, and sometimes the tip isn't as hot as it kind of should be as the rest of the iron, you know what I mean?
Yeah.
Doesn't seem like you're having an issue, which is
Nope.
good. Yeah. So back to the kit instructions. You just want to do all 32 connections, 2 per resistor, which David is doing. So I'm going to jump over. Oh, cool. We have someone in the chat.
Nice.
JJ. I love the idea of you guys. I've seen you at the past couple of Buffalo Mini Maker Fairs. Will I see you there in a week?
I believe so. Yeah. We have, I think Christopher Poole is the guy who designed the solder badges this year, but they look pretty cool. They're a little PCB in the shape of a 4, because this is their 4th Maker Fair. So yeah, hopefully we'll be there. Plan to.
Like with a booth?
Yeah.
Cool. So, yes, we should be there.
That would be fun.
Typo. If anybody watching has any questions about the kits, about Thimble, about electronics, feel free to post it in the chat. We'll definitely answer it. Yeah.
Cool. So I gotta step away to go grab my tools. Don't
Okay.
have them all laid
Yes,
out.
we have the full toolkit over there on the other table. So David finished soldering. We can kind of take a look at the solder joints. And we can see, oh, this is difficult. Kind of what they look like. Yeah.
Cool. All right, so I have my diagonal cutters, and I'm just going to go around and trim all of the leads of the
Important thing to
resistors.
note, David is wearing safety glasses. I have
am.
glasses, which aren't a perfect safety thing, but David's holding the leads before he cuts them. He's not just cutting them and having them fly into the air.
Yeah, I'll do one. It did fly.
They do. They most definitely do.
Oh yeah, no, they normally do.
Yeah. So yeah, definitely with the safety glasses. There's nothing inherently dangerous to your eyes with soldering.
Well, it's good to wear safety glasses while soldering because sometimes the solder will, like if it gets a little air bubble or something, it'll actually
It kind of pops.
pop a little bit.
Yeah.
And so you can burn your hands that way, or if you get really close with your eyes, you could actually have some solder spurt out into your eyes. I was actually talking to my dad, and so he works as a technician, and when he was in school learning how to solder, he actually had some solder go into his eye, and it didn't affect his vision at all.
Did it
was a
hurt?
very small amount, and it hurt very much.
I can see that. I can see that.
Yeah.
Yeah. So definitely wear safety glasses, but also you can help minimize, possible injury by just doing safe things like what David's doing with these clippers. He's not looking right over it while he's clipping them. He's kind of far back. Yeah.
There we go. All right, so we have
all the resistors.
all of the resistors soldered. So what's the next step on the website?
So the next step on the website, which keeps not working, is to do the LEDs.
All right.
So why don't you tell us a little bit about the LEDs? I know they light up. What else do I need to know?
Yeah, so LEDs are diodes. It stands for light emitting diode, and a diode is polarized. So you want to make sure that you place the LEDs in correctly. You can see on the PCB we have the negative side facing outwards from the PCB, and it's all labeled for all of the LEDs. So the negative lead is the shorter lead on the LEDs. So when we place them in, we want to make sure that the shorter lead is facing towards the outside.
So if I put the LED the wrong way and I try to power up the kit, am I going to break the LED?
You won't break the LED, but the LED will not turn on.
Okay, that's
Which is
good
what
to
you
know.
want. Yeah. So actually, if you watch the videos, we put one LED in backwards as a demonstration to show how to fix it. So you just have to desolder the LED and then flip it around.
Cool, that doesn't sound too bad. And again, these LEDs are through-hole components, which means they go through the holes of the PCB, and so it does help to kind of give the leads a bend, and you don't want to bend them in the same direction because you're going to be soldering them later. So it just kind of you don't want to make it more difficult for yourself. So you can see David's bending one side kind of off the PCB and one side towards the middle of the PCB, because that's just kind of the direction that the LEDs are placed in.
Yep.
Yeah.
Placing LEDs. What fun.
Yeah. So, can we talk about the next kit?
Sure.
Can we reveal the next kit?
Yeah.
Okay.
So it's not fully assembled, the one right there.
No, this is a preview.
Yeah.
Okay. So while David's doing that, he's just going to be doing the same thing that he's been doing for the rest of the LEDs. This is kind of what the next kit looks like. I'm keeping it far away for a reason. It's a internet-controlled light switch. So it just kind of goes on the light switch plate that you already have. And there's a little servo. There's some plastic pieces that we don't have. This is just kind of like the assembled PCB with the Arduino board and the Wi-Fi module, which if you got the Wi-Fi robot should look familiar. And the servo just kind of flicks it on and flicks it off, so you don't have to open your junction box and mess with the wires with a relay. This is just kind of lo-fi, but I think it's a good engineering solution.
Yeah, it's fun. I'm actually using one at my apartment.
I could use one because I always leave my light on, then I go into bed.
Oh, really?
And I'm ready to go to sleep, and I'm just like, I wish I could just turn off that light without getting up.
My bedroom doesn't actually, I live in a very old house, and my bedroom does not have any light switches.
Oh.
Because I haven't redone the wiring at all.
Gotcha.
So I have a bunch of those little remote control relays.
Mm-hmm.
I flip them on and off that way.
Okay, cool. So this is like the first step someone could have into having a smart home.
Yeah.
I like it.
And it's DIY.
Okay, so we're going to go back to watching what David's doing, which is just going to be more soldering, but these leads, or the holes in the PCB are a bit closer. So I guess in that way it's a bit more difficult, but if you just take it slow, one joint at a time. This is something you really don't want to rush, just because if you rush, then you get a solder bridge, and it's not the end of the world, but like I said, you don't want to make more work for yourself.
Yeah, so you definitely don't want to bridge the connections, which would be having like a big solder ball on there that touches both leads of the LED. Since one is the positive side, or the anode, and one is the cathode,
Negative side.
The LED will not work if you bridge them together.
A lot of components won't work the way you think if you bridge connections.
Yeah.
Important to note.
You'd be creating a short circuit then. So like if we short circuited a resistor the current would all flow through the short circuit, so we wouldn't actually have the resistance value that we want.
Yeah, so the resistors, what they do is they resist the flow of electricity. So it just makes it harder for electrons to pass through from one location to the next. And so when you short them, the electrons aren't going to go through the really difficult resistor. They're going to want to go through just the normal solder joint. A lot of people use either water or traffic as an analogy for that. So if you had, two roads to choose from and one has a bunch of traffic and the other is perfectly clear, you're going to want to take the perfectly clear one if they could both go to the same place.
Yeah, I actually really like the analogy when we were talking the other day. You mentioned like a physical activity for like school children to teach resistance would be having them walk around a room.
Yeah, so the idea behind that was they walk around a path, and then so that would be no resistance, would just be a clear path. You walk around, it's pretty easy. And then a path of resistance would be with stuff in the way that they have to avoid or climb over, and it would just take more time, it would take more work. And I think that's a good physical connection to what's happening, at the electron level.
Yeah.
Because to go through a resistor is more work, it's stuff like that. Okay, so David finished soldering all the LEDs. So he is chopping off all of the excess leads.
So these ones fly a little bit better.
These definitely
since
fly.
The metal is a little bit more brittle. You can see it definitely flew over.
I'm seeing them.
Yeah.
None are landing by me though, so good job.
It's good.
Yeah. Yep, so he's going to trim all those leads, and while he's doing that, I'm going to take a look at the next step in the directions, which is soldering the headers. So the headers are what connects the Compass PCB, or printed circuit board, the thing that David's working on, to the Arduino, which is the microcontroller. It's the brain. It's where we upload the code, and that actually drives all the circuitry on the Compass. And the headers are necessary to make that connection. You can see on your Arduino that there are 2 lanes of headers. And so we are going to be connecting those 2 lanes to the PCB. So why don't you talk about that?
Yeah, so I'm just inserting the headers now. If you look at the PCB, the footprint for these headers, the pins are a little bit offset to try and hold them in place to make it a little bit easier on you. So for soldering the headers, we're just going to first do one solder joint just to tack it in place, and then we're going to check that the headers are actually
Straight.
Yeah.
Because since it's a little difficult coordinating 4 separate header things with the Arduino, but it's definitely difficult to coordinate that after you've soldered them all together onto the PCB. So just doing one, taking a look at it, making sure it's straight, I would definitely recommend.
All right, so we have all of them tacked. Now we're just going to flip it over and look, and they all seem pretty straight.
So what if they weren't? What would I do?
If they weren't straight, you would hold one finger on the plastic part, put the thing sideways, and then use your soldering iron to heat up the joint that is holding it in place, and then just rock it back and forth and push it on until it stays straight.
Okay. Doesn't sound too bad.
Nope.
Yeah, and in the little plastic bag with your smaller parts that come with the kit, there are 4 separate headers, and they all have the correct amount to only go, well, there are 2 of them that are the same, and then there are 2 other ones. So there are 3 different headers. Yeah. You can see it a lot better in the you can see it a lot better in the pictures on the website.
Yeah, they line up with the Arduino.
Yeah, they all go in only one way.
So that's not true.
I know, I try to make it simple. 2 of them are interchangeable. So you put the headers in.
Make sure, yeah.
I would be surprised if you could get all the headers in the wrong way.
You could put them upside down.
That's true, so that's a good point. Is that the male part of the pins, which is the part that sticks out, the metal part, not the plastic part, they should be facing, they go through the top of the PCB, pointing out the bottom. So what David's doing right now, that's the correct orientation. And again, it's just soldering. This is smaller distance between the 2 pins than the LEDs?
Maybe a little bit, yeah.
Okay.
It's 100 mil pitch.
Yep. And the same thing, you definitely want to, less is more with soldering. It's much easier to add more solder than it is to take away. And when, say you put a little bit of solder and you look at it and you say, well, that's not right, there's really just not enough there, you don't just put more on. You have to heat up the pad again, make sure the solder kind of gets shiny and molten, and then you could add more. Yeah. Would you agree?
I would.
Okay. David is just about finishing up with the pins, right?
Yep, got one more joint to go, and then we're ready to move on to the next step.
Okay.
Alright, so once you're done with the soldering, just kind of visually inspect your joints. Looks like I have almost a bridge right down here, so I'm just going to reheat that and let it flow a little bit more evenly.
Yeah, and if you have a bridge, you can reheat it, and if you can't quite get it to separate, I would suggest using a solder sucker or a solder wick. We have those tutorials online, and you just want to try and take off the excess solder and kind of start over and try it again. So the next step is battery pack, but before we do that, David's just going to make sure that the headers are actually, straight and they'll go in the Arduino, right?
Yeah, I was skipping the instructions. Actually, I wasn't looking at what the next step is. So the battery pack is next, huh?
Battery pack.
Cool. So I think we're just going to attach that to the Arduino, so that's pretty easy to do. We have some double-coated tape on the back of each of these pieces of Velcro. So just peel off the tape.
I found it extremely difficult when I did my kit.
To peel the tape off?
Yeah. So what orientation should the tape be going on? Or does it not matter?
It doesn't really matter. I mean, the only thing that you really want to check is that the barrel jack connector on the battery pack is the right orientation for when you plug it in to the Arduino. Like that. There you go.
Like, so this is the correct way. That way also works, but what you don't want, this is kind of tough to see, is for the kind of wire to have to, you can see kind of the stress of it pulling down on the barrel jack. You don't want that. It should just, have a decent amount of slack.
Yeah, and since it's Velcro, you should be able to rotate it around if you do put it in upside down.
Yep, so David just took off the adhesive on one side of the Velcro, and he's attaching that to the battery pack. He's kind of looking at his, giving them play-by-play.
Trying to decide which way I want to put it on. Alright, so put one piece onto the battery pack, peel off the other side of the adhesive, and then just stick it onto the Arduino. And make sure that it's a good connection.
Okay.
Cool.
Cool. Looks good.
Yep. So now you're able to actually
It's good Velcro.
peel it off.
This is official 3M Velcro.
They do make their Velcro well.
Okay, so now with the headers soldered on, the battery pack is good. David is going to mate the headers that we soldered in the PCB on the compass with the headers on the Arduino. And it's a little tedious.
Yeah, so these pins can bend, and the reason for that is to make it easier to connect them in case you were to put the header on the wrong way. You'll be able to bend the pins, or not on the wrong way, but on at an angle. You'll be able to bend the pins and straighten them out to still have it mate with your Arduino. But it is a little bit tedious to try and get this connection.
Then you do it and it feels great.
Yeah. So I like to try and line up one set of the pins and then line up the other. And they're pretty close.
I like all the music.
Oh, the little time kind of music box sounds.
Okay.
Alright, so just gotta push these in a little bit and then they'll go in. Not quite.
You want me to give it a try?
What? I'm almost there.
Okay.
Don't rush me.
Not rushing you.
And
Sometimes, just a fresh set of hands helps.
alright, there we go.
There we go. Okay, so now the headers are in the Arduino. Our battery pack and Arduino have the Velcro. We can go on to the next step, which is now software stuff. So, I guess I'll just do a monitor share.
Sounds good.
Okay, so we are now at the software section of the learning platform for this, and we're going to check that all the LEDs are soldered correctly and our resistors too. So we're going to download, oh, did you save this as a, hey, look at that. Okay, cool. So we can just take this, go and copy all of that. I have my Arduino ID. We'll start fresh. Delete what's there. Paste in what we have. Okay. And now David is going to connect the Arduino to the computer using the USB cable. And when he connects it, it should turn on. The LEDs probably shouldn't turn on, but you should be able to see the power light. So we are going to go to Tools, make sure that we have the correct board set up, which is Arduino Genuino Uno, just right here. I'm going to select my port, and it says Arduino Genuino Uno. So I'm going to select that. So these are correct. Programmer should be this one. And we're going to upload the code. So LED test.
So what it actually does when you hit the upload button is it compiles the code and it's generating a binary that it then upload to the Arduino through the programmer. It's taking quite a while. Alright, there we go.
This computer's doing many things right now.
Yeah. Okay, so now you can see the code has been uploaded and it's running the LEDs through the test pattern, so it's lighting up 4 LEDs at a time in the different quadrants of the compass. So it looks like our soldering went well and the LEDs work, which is good.
Yeah.
So I think we're ready to move on to the next step, which is the magnetometer test.
Okay, so we are now back on the page. So we did the LED test and it worked, which is good. So now we are going to do the magnetometer test. Same thing, we're going to click that. Okay, let me make that text. So we're just going to go right from the file. Okay, cool. Everything's there. Again, we have our board and our port, and we're going to do the same thing. And so what is this doing?
The magnetometer test is
well, first, what's the magnetometer?
So the magnetometer is this little piece right here, and it communicates over I2C, which is a communication protocol. And the magnetometer will read, so it has it's a MEMS device, so it has a bunch of little pieces in the silicon that it can actually react to magnetic fields, and the Earth has a pretty strong magnetic field, so it's actually reading values from the magnetometer through the I2C interface and then printing them out on the serial port, which is what you're seeing right there.
Yeah. So we have done uploading. The LEDs on the board have stopped kind of changing around. And so I'm going to go up here where it says serial monitor. You can also get there by going to tools and then serial monitor. And so anything that the Arduino sends back to the computer is going to show up in the serial monitor. And if you don't see this, make sure that your baud rate, which is down here, which is kind of an agreed upon number that the computer and the Arduino have.
Yeah, it's a speed that it's communicating at.
Yeah, is set to 9600, and we can also see that it's set to that
in the setups section of the code.
Yeah. So we see that it's set up to 9600 here, which is why we should match it there. Okay, so what am I seeing? What is 240?
So you're actually seeing the reading from the magnetometer directly, and it's converting at 2 degrees. So I actually have a magnet that I'm pulling out. It's a very tiny neodymium magnet. When I move it, you can see maybe that the reading from the magnetometer is actually changing in response to this little magnet.
Yeah. So if I don't have a magnet, how do I test this?
You can rotate it around, and you'll see that the values also change.
Cool. Okay, so
Cool.
this means that your headers are in?
Yeah, so everything's working, so we can actually upload the final code.
Okay, so I'm going to go back to the learning platform, make the compass work. Final code is there. Gonna grab that. Can X out of that, we don't need that anymore. LEDs work, we're okay.
Cool.
Just gonna make this a bit bigger. Okay, and we're gonna just double check that, yep, these are good. They don't really change if you don't touch them.
Well, they might change if you unplug the Arduino and plug it back in.
That is true. So, same thing that we did before. We're gonna upload it. Still compiling.
Cool. Now it's uploaded. Or no, it's not. It's uploading. And now, there we go. So, the LED that's lit up points north, so if we want to actually use our compass rose on here, well, I can't quite rotate it.
Do we
don't have enough slack in this. And we don't have batteries. We should have grabbed them. But that's okay. But you can rotate the compass so that it points north. So now you can use the compass rose to see the direction of east, west, and south.
Okay. And there's something else that we have to do.
Which is
right?
what?
Calibrate it?
Right. So you hit this button here, and then it goes into calibration mode. And while it's in calibration mode, you want to rotate it around in a circle so that it is able to calibrate well. So you can see the direction of north change just a little bit.
Okay.
And that's it.
That's it. So do you want to go through the code?
Yeah, let's go through the code.
Okay. So this is the final code that's running on the compass right now, where we tested everything works, and this is kind of everything put together.
Yeah, so let's go through it starting from line 1 right at the top there. The pound include statements include the libraries. So the wire library is the I2C library for Arduino, and then we're also including the EEPROM library, which stores the calibration values in the EEPROM memory of the Arduino. So it actually writes those so that when you lose power and then power it back up, those calibration values will still be stored. The next 3 lines are...
should we talk about, like adding libraries? What are libraries?
Yeah, so...
so everything that you can kind of do with the Arduino is not necessarily in there right away, I guess is the good way to put it.
Sure. So, well, I guess the general concept, so I'm thinking of, yeah, anyways. The general concept for libraries is that, you're going to have a lot of code that's reusable when you write code for a computer or a microprocessor in this instance. And it's good to use, write that code so it can be reusable in multiple projects. So rather than having to write an I2C library every single time we want to talk to an I2C device, you use a library that abstracts away, the specific commands that we're sending to this specific device and makes that code be reusable. So there's a lot of libraries that exist for Arduino. You can go into why don't you show the library manager where you would install new libraries.
So these are libraries that they already have. So say I want to hook up an SD card and log data. There's an SD card library. If I have certain Arduinos that have Ethernet sockets on them, I can do this and do some internet stuff.
Yep.
In the last kit, there were LEDs that were a little bit more advanced than these.
Yeah.
So they needed a library because someone else wrote all of the commands and stuff for that, and so why not use it?
Yep. So click on Manage Libraries, because
okay.
that makes it really easy to add new libraries. So
what's a library that I probably don't have that I should have?
Servos. So the next kit uses servos, and so you type in servo there, and you can see there's a bunch of libraries available for servo motors, and there should be one that's just called servo.
I think I have that.
Oh, maybe it's already installed. Yeah, it is.
So I have this.
Okay.
Because I have the fancy Adafruit IDE. Yeah.
So that includes all the libraries you'll probably need.
Yep.
Cool.
Wi-Fi. I did a project that used specifically the Wi-Fi modules that are on the the light switch in the robot, and there's a library for that. So I didn't have to write that myself. Cool. I could just reuse it. Okay. So those are libraries. So what's going on here?
Yeah, so lines
and I guess here
4, 5, and 6 are, so pound define is a macro. It's for the C macro preprocessor, and it's basically just saying anywhere I use data, replace the character data with the number 9. And what we're actually using this for is defining which pins on the Arduino are connected to the magnetometer, and in this case actually it's all for pins 9, 10, and 11 are connecting to the shift registers that control the LEDs.
Yeah.
Why don't you bring up the schematic real quick and we can show
Sure.
what that looks like.
Where can I find the schematic?
I think it's on the troubleshooting page at the bottom. Cool.
God, I don't want that full screen. Okay, so where should I be looking? Here?
Yeah, so the level shifting over there, that shows the clock, latch, and data lines connected to that header, and if you scroll down a little bit, the Arduino connections there shows 9, 10, and 11 on the Arduino are connected to data, latch, and clock.
Which, if we look, do this a little side by side, we see that 7 is, oh, this is the wrong
No, it's
Arduino.
actually, so those pin numbers don't match up with the Arduino pins. So it's 9, 10, and 11.
9, 10, and 11. But we're using the names data, latch, and clock, and we have data, latch, and clock here.
Yep.
So you use something like this to make your code more readable.
Yeah.
Because, just seeing a 9 is kind of like, you have to remember, well, what did I assign to 9? What is 9 doing? Whereas, later on in the code where we see, oh geez.
It'd be in the update LEDs function. Update shift register, sorry.
Yeah, so seeing data kind of makes more sense to us as people, and not computers, I swear. Makes a little bit more sense than just seeing 9 or 10 or 11. So we do it for readability.
Yep.
And also because it's easy to change.
Yep.
Okay.
In case you're wanting to change which pins are connected. You can't do that with a PCB, but if you're wiring it to something else, you could.
Yep, like into a breadboard, and suddenly, you have a thing connected to pin 5, and you don't want to have to go through all of your code to change, 5 to something else. If you did something like this, let's say, we magically changed the data to pin 8, then all of it's updated.
Yep.
But we didn't, so it's 9.
Alright, and then we're using another pound define to define the address of the HMC 5883L, which is the magnetometer that we're using.
Yeah, this is just the fancy part number.
Yep. Then we have a couple of bytes there.
And these are kind of like for...
They're holding the status of the LEDs.
Okay.
Yep.
So they're just variables, kind of need them.
Yeah, they're variables that say which LEDs should be turned on.
Okay, this is kind of self-explanatory because we have your comment over here. But, yep, 360 divided by number of LEDs divided by 2 degrees per LED. So that means that...
Yeah, so there's 360 degrees in a circle and 16 LEDs. So we're using that variable, which is a floating point number, to determine which LED should be turned on.
Okay.
So our magnetometer actually has 3 degrees of freedom, so it has an X, Y, and Z magnetometer inside of it. So it says, when we're reading from it, it writes out those 3 variables, X, Y, and Z, which shows the strength of the magnetic field in the X, Y, and Z directions.
Cool. Bearing.
Yep, that's our final result for the bearing, which is the direction that the compass is pointing. There we're reading the calibration values from the EEPROM memory.
Okay. So now this is kind of all variables and stuff that we want to do before the compass is running.
Yep.
So now we're starting to get into kind of what makes the compass work. So
Yeah. So we...
I can take over here.
Sure, go through it.
Okay, cool. So we have this function called update compass XYZ, and we can kind of take a look at it. Anywhere you kind of see wire dot something means it has to do with the communication between the sensor and the microcontroller, the Arduino itself. So this is how they talk. So this kind of starts the conversation, it tells you, where you're going to be talking to, because we are programming the microcontroller, and it's going to then talk to the sensor. So that's why we have the address of just the sensor. We don't need the address of the Arduino, because we are the Arduino in this case. We have it writing some data.
Yeah, so that's setting values within the magnetometer. So if you look at the data sheet for that magnetometer, you'll see the addresses and the values, and those are set.
Yeah, this is set by the
values.
manufacturer. If
Right.
you want to interface with this, you have to do it this way. It's just how it is. And then end transmission.
So exactly what that's doing is first select the mode register and then write the value of 0, 0 to set it into continuous mode, which means just give me continuous readings from the magnetometer.
Which we want, because we want to keep getting the information. We always want to be accurate. We always want to be calculating which LED should be lit up, and then end. Then this.
Yeah, so then we start reading from the magnetometer.
Cool. So, update LED. Oh. And then there's the rest of the code. There's the rest of the owl. Okay, so I'm not going to do that again. Nice. So, void, update LEDs, and we'll start with this part kind of right here. So this is the name of the function, update LEDs. You could name it whatever you want if you write your own code, but again, we want our code to be readable because, it's us writing it and having to read it. So update LEDs, I wonder what that does. It updates the LEDs. And see here, between the parentheses, before you get to these curly curly braces here, is what you can put, what the function needs to...
The inputs.
Yeah, okay.
Yeah.
The inputs. So we have input bearing, so after we've calculated, what LED should be lit up, we give it to update LEDs, and update LEDs does the rest.
Yep. So then inside of the brackets is what the function actually does.
Which
you
is...
can see from the comment,
Jeez.
Once we scroll back to it, set output data to always light the LED facing north.
Yep.
So what we're doing is we're reading the bearing, and based on the value of the compass bearing, we're determining which LEDs to turn on, and that's what's happening with all of these if statements.
Yeah, so there are 16 LEDs, and are there 16 if statements?
Looks like there are.
Okay, so that means you calculate your bearing. Say we saw the number 240 before in the magnetometer test. So if it was so if we pass 240 to this function, it would keep going until it finds, a bearing that's between something and something where it's 240.
Yep.
And then once it finds that, it looks to, the next part and translates that into an LED that should be turned on.
Yeah.
It's kind of the abstract way. So I'm sure we'll look at actually how that happens a bit further down in the code for the shift registers.
For the calculation, writing out to the shift registers.
Yeah, because at the end here, so this is a function, update LEDs, but we can see that there's actually another function within it.
Yep, so that updates the shift registers. So all of the LEDs are connected, if you go back to the schematic, to the shift registers. So if you scroll over to the left a little bit in the top there, you can see there's 16 LEDs and there's 2 shift registers. Each shift register has 8 outputs.
So why can't we just connect the LEDs to the Arduino?
Because we don't have enough pins on the Arduino to connect all 16 LEDs and the magnetometer.
So the shift registers allow us to almost get more pins.
Yeah, exactly.
So what we do with the shift registers is we send them data, and then they kind of handle the LED stuff.
Yeah.
What a great engineering solution, David.
Yeah.
Okay. Calibrate compass. Again, this is pretty readable. We know what it should do, and that is when you press the button, the LEDs go around, you rotate it. This is probably something that is in the data sheet for the magnetometer.
Yep.
And you just kind of followed what they gave you. Kind of don't want to go through all this. That's quite meaty.
There's not that much left. So, oh, well, I guess we can skip through the calibration code, but it's fairly well commented, so it kind of explains what's happening. Basically, you're calculating an X, Y, and Z offset, and if you look at the learning tutorial, we explain why you need to calibrate it.
Yes. Okay, so now we're kind of getting to a part that you might see in other that you definitely will see in other sketches. So I'm just going to bring up a quick example sketch, which is the blink sketch, which just blinks an LED, and we can kind of see some similarities. We see a void setup and a void setup, and we see a void loop and a void loop here. So these are things that you need in every Arduino sketch, and by the way, sketch is just kind of the place where all the code goes for a certain program. So like this window is a sketch, this whole thing is a sketch, and each sketch needs a setup and a loop. The setup runs once, it's usually for setting things, so we can see here we're initializing the communication from the Arduino to the sensor. We're setting up that number that the Arduino and the computer agree on to send data. Then we're setting what the pins that we defined earlier, but now we're actually setting them. So yeah, the setup is very much a place where you set things up.
Yeah, and that pin 5 there, that's the calibration button. So we set a pull up on that.
Yep. I'm sure if we go over to the schematic and we look for a button.
Right there.
Yep. We have a little switch here, and
so it goes through a pull-up resistor inside of the Arduino and then connects directly to ground. So when we read the voltage at that pin, it's usually high, and then when we actually close it, it goes low.
Yeah, so when you press it down, makes the connection to ground, and that's low.
Yep.
Cool. Okay, so we've seen this before. It was definitely in the update LEDs register. I've seen it kind of sprinkled upon the sketch a lot. So it's probably important. What does it do? So it says update shift register, so I'm assuming it updates the shift register.
That's exactly what it does.
Cool.
So we so the shift register, there's a more detailed description of how it works in the further reading section of the learning tutorial, but basically you shift the data in. So you can see that we're shifting out from the Arduino into the shift register with that shift out function, and it takes 8 bits, so one full byte at a time.
Yeah, so you can see we have 16 LEDs and we have 2 shift registers. So I'm going to pop back to the schematic. The reason that it takes 8 bits of information to shift into the shift register is because it controls 8 different things.
Yep.
So say we had a shift register that only controlled 4 things, we would only have to push 4 pieces of information in. So we calculate the bearing, that gets set to the update LEDs function, that figures out which LED to set, and that passes it to update shift register, which is kind of what's happening now. So then,
yeah, so we write the latch low,
which means we're about to write to it.
Yep, and then we shift in 8 bits, and then we shift in another 8 bits, and then we write the latch high, which actually updates the LEDs.
Yep. So get ready for it to write. Write to one shift register, write to another shift register, and then say we're done. We're done writing.
Yeah, and if you go back to the schematic real quick,
Sure.
So that we're actually only writing to one shift register because the output pin of the one shift register is connected to the input pin of the other.
Yeah, so these are they are acting as one bigger shift register because you're shifting out of this one, but anything you shift, you fill this up with 8 bits and then you put another one into it, well, the one that you just pushed out, now it goes to the other.
Yep, so we're shifting 16 bits total.
Yes, so we're acting, 2 of them in series, acting like one big shift register.
Yep.
Okay, so now we're at void loop. And so void setup only runs once because you really only have to set everything up once. Void loop is kind of where more of the functional aspects of the code go. And this runs all the way through, gets to the end, runs all the way through, gets to the end, all the way through, and it just keeps going and going and going as long as your Arduino has power.
Yeah, so you can see from the comment there, when the button on pin 5 is pressed, calibrate the magnetometer. And then we have an if statement, and that exclamation point right there in front of the digital read. So we're reading from pin 5, which is the calibration button, and we're saying if it's not a high value, then run the calibration function. So like I said before, if you look at the schematic, as you're running through the code, when the button's not pressed, it's going to be in that high state because we set that when we set the input pull up. And then when it goes to low is when you want the calibration function to run.
Cool. We have this.
Yeah, so we call the update compass function that reads from the magnetometer and updates the compass. And then we apply the offsets to those values.
Calculate our bearing.
Yep.
And then
convert from radians to degrees.
Which is math stuff. It's trigonometry stuff.
Yeah. Set the range to 0 to 360. And
cool.
Then we print out the bearing on the serial monitor. So
which we should probably actually be able to see.
Yeah.
Yep, there we go. So right now it's at about 122, 123 degrees, which is why the LED that's lit up is. And then we update it with the bearing. This was like the first thing we went through.
Yep.
And then we wait. And then it starts all the way back at the loop again and keeps running through.
And continuously updating the code. So that's it.
Yeah.
How many people are watching the live stream?
Like one.
Cool. Any more questions?
Yeah. I think this went well.
I think so too.
I think it went better.
Yep. All right. So doesn't look like there's any more questions. So we'll go ahead.
0 drop frames.
Yeah, we'll go ahead and sign off. Thank you for watching. Hopefully the code description there was helpful. That's something that we're working on improving for the learning modules.
Definitely. And we're also going to go, if you've never touched Arduino before, if you're having some issues with the software, we are going to be putting out a tutorial that kind of takes you from, I've never touched an Arduino, I've never coded anything, and it kind of takes you through getting that set up.
Yeah.
Like with the environment, what's a sketch, what's the pin mode, basically everything you need to kind of make your own sketches. Yeah, we're going to be going through that. That should be up very soon, definitely by the end of the month.
Cool.
I'm willing to commit to that.
All right. Let's
Definitely by the end of the month, before the next kit goes out.
All right. So with that said, thanks for watching, and we'll just sign off with that.
Okay, cool.